Oh, you can't see it. Don't go. Hello and welcome back to Calculus 1, section 3.2 on derivative as a function. So in this section, we are going to build up on the idea from last class where we said that the derivative is a function which generates all of the slopes to tangent lines that we can draw at every point of the function. So if you remember, let's say that was the function. Not sure why it's purple, but it's okay. We can have a tangent line here on top, and it will be horizontal. We can have a tangent line right here, a tangent line right here, tangent line right here. So every point along the function is going to have the tangent line, and those tangent lines have numbers. And then those create a new graph, which is a function, and we call that function the derivative function. So now, the question is, can we draw the derivative if we have the graph and we don't know what the function is? So, if I have f of x and I have all these points, and we know that we can draw little tangent lines everywhere, can I somehow draw the graph for the function without actually knowing what that function is, what the derivative is? And the answer to that is yes. We can sketch it. It's not going to be perfect, but it's going to provide enough information for us to actually use for what we needed. So let's go and take a look at the simplest example first. So let's say that we go at 45 degrees 4 units. Then we go 3 units like that. Then we go 1 unit up 2 units. Go flat 1, 2, 3, 4, 5 units up to 13. And then drop down 1, 2, 3, 4, 5, so to 18, and that would be our, this black function is our f of x. This could be you driving. Let's say your velocity is 0 while your car is in driveway, I hope, right? And then you press the gas pedal, and then you drive at a constant speed, and then you speed up, and then you drive at a constant speed, and then brake, and then you stop. So that could be the graph or something like that. Can we draw the derivative just by looking at this? And the answer is yes. Because remember, the derivative is slopes, right? So what do I get to draw? Now I'm going to draw derivative red. What do I get to draw between 0 and 4? 1. Very good. I get to draw this. Because the value of the slope from 0 to 4 is 1 all the time. What do I get to draw from 4 to 7? 0. Why? That's correct. Why do I draw 0? The slope is 0. There is no change on this part. Derivative measures change. Well, this is flat. There is no change on flat. There's no slope. Slope is 0, so we draw 0. What do I get to draw for this piece between 7 and 8? 2, because the slope is 2. How about 8 to 13, this piece? 0 again, very good. And then finally, what do I have here? Well, what's the height? 1, 2, 3, 4, 5, 6. So height is 6, and this is 18 and 13, 5. So he's getting there. Negative 6/5. Ah, yes. Negative 6/5 because the function is decreasing. So what we learned from this graph are 3 very important, and we'll have another 2 when we're done. So 3 very important connections between black function, which is f of x, and the red function, the derivative, f prime of x. So black line, right, the black function there is f of x, your original function, and the red function, which is this piecewise function, is going to be the derivative. Please notice that any time when your function was rising, you had positive slopes, positive derivative. Anytime when function was flat, you had zeros, and anytime when the function is decreasing, you have negative derivative. This is what we are learning in this section. Now we write that in words. If f of x is increasing, f prime of x is positive, so we just write bigger than 0. If f of x is constant, f prime of x is equal to 0. If f of x is decreasing, f prime of x is less than 0. So these are the 3 rules that we learn and discover from the graph above. This is coming back in chapter 4. This is coming back in Calc 2, Calc 3, differential equations. This is something that it's key to understanding between function and the derivative. Next piece of the puzzle is now the line is going to be curved. So I'm going to have something like this as f of x, and I'm just going to set that somewhere in x, y, doesn't matter. So again, I have a black line, black function, that's going to be my f of x, and I'm going now to red to draw the derivative. I'm going to start, this is the new thing you're learning now, at max and the min point, because they have at that point what we call horizontal tangency, where slope is what? 0. This is where your derivative will cut through x-axis. So you see those purple rules? The new purple rule is at max and the min of your function, you have the x-intercept or a root for the derivative function. That's the new rule. So now I have these 2 points, and I know that my derivative is going to go through this. So what do I know? I know that this part of the line is increasing. I know that this part of the line is decreasing. And I know that this part of the line is increasing. Right? We have 3 segments of this graph: increase, decrease, increase. So now, please look at the screen, and you can draw this thing that I'm going to have in literally 1 second. I'm going to have this, okay? So you can draw that very fast. Please look at the screen to understand what happens here. These are my guidelines. To the left of the first pink line, the function is increasing, which means that the derivative has to be positive. That is in this box up there, the first line. If the function is increasing, derivative is above x-axis. So, combine the knowledge that you have to go through this point with the knowledge that on this side of the graph, your derivative has to be above x-axis. The only thing that you can draw is this. You can't draw anything else because it has to hit that point, because it has to pass through the point because of the maximum value. So it has to hit the point and it has to be above, right? Now, in the middle over here, function is decreasing, which means that the derivative needs to be below x-axis, and it has to hit 2 points on the side. There we go. Yeah. So, the only piece that I should draw would be this piece, because it has to connect 2 points, and it's negative. I mean, if you have 2 points, can you connect it this way? Sure, right? It will be wrong, but just connect it, right? And then finally, in the third region, we have increasing, so derivative has to be above, and that's my f prime of x. I told you it's just going to be this. But you don't get to draw it in one shot. You have to draw this piece separately from this piece, separately from that piece. And now we can get rid of these guidelines. And now we also learned one more point that we add to our thing here. And that point is that f prime of x equals 0 when f of x has max slash min. So this is your next key point to understand. And as I said, this is coming back in chapter 4, coming back Calc 2, Calc 3, differential equations. You absolutely must know these relationships. The final one, the fifth one, is the one that is a vertical asymptote. So we're going to draw our good friend 1 over x. But I'm going to pretend as I don't know it's 1 over x. It's just, you know, a random function that I plugged in, it's f of x. That's all it is, right? So now we are learning the next purple statement. And the next purple statement is that the vertical asymptote location is preserved as you go from function to the derivative, okay? So vertical asymptote location as we go from f of x to f prime of x is preserved, meaning at the same location. So where is my vertical asymptote? Where is my vertical asymptote? 0, right? So here's my vertical asymptote. I'll call it VA, and that's x equals 0. Please don't trigger my allergies, because I become extremely allergic to you if you write something like that. This has no meaning in mathematics. Okay? So don't write it. You have to say vertical asymptote at, if you want to abbreviate things, you have to write x equals 0. This is equation of the line. And this is what the entire world understands. VA equals to 0 means nothing. Okay? So don't write it. So I have a vertical asymptote. Yeah, I'll write it here. Vertical asymptote at x equals 0. All right. Do I have min and a max? No. I don't get to use the previous thing. But I do have that both of these are decreasing, right? So if I have that this is decreasing and I have that this is decreasing, by the first purple collection, we know that both parts of the derivative have to be below x-axis because they're both decreasing. And in addition to that, we know, I just wrote it, that the vertical asymptote stays where it is. So the only way to write this is to put your red ones like this. And that's f prime of x. Because they have to follow the blue asymptote. They have to be under x-axis. There's no other way to draw them. There's absolutely nothing else you can do other than to draw that. You have to be under x-axis because decrease for both of them, right? These are curves, which means that your slopes are not flat lines because the slopes are not constant. So you have to use curves. They have to be below x-axis. They have to follow the vertical asymptote x equals 0. There is no other possible way to draw those two red lines. Now, for this particular example, we are lucky that we did some calculations previously in one of our previous classes, and we said that if f of x is 1 over x, the derivative is, does anyone remember? Exactly what we see as the red line. Because the graph for 1 over x squared positive looks like this, right? And then when you add a negative to it, you are reflecting it, and it becomes that. Your calculations and graphs and all of those shifts from pre-calc, this is mathematics. They all have to lock in, right? If one of them is off, then that concept is not sound, and we never use it. In mathematics, everything has to click across all of the things you ever learned every time. Which is why many argue that the further you go in math, it becomes easier because you just have a lot more knowledge and you see how the things click across, right, multiple. It's like when you have a lot of jigsaw puzzles pieces already put in, and then you are bringing a new piece, and you just have a hole, right? Rather than when everything is blank and just pick up a random piece, like where does this go, right? I usually say, I used to put those when I was in high school, because I used to love to listen to music a lot. And I noticed that no one would bother me if I just put the piece of puzzle and then listen to music. No one usually asked me anything. So I used to put those pieces together. So sometimes my sister would join or a friend. And I say, you see this piece? it goes somewhere. And then I just put it back on a pile because you really can't do anything. You have to go with the, right? So that's that part, right? It has to click across the board. So we have the black function up there, 1 over x. Then you have the red function, negative 1 over x squared. If you run your calculation with the limit, and I think we did that last class, right? Did we do 1 over x? I think we did. There it is. Find the derivative of 1 over x, and we got it, negative 1 over x squared. So last class we did that, and now you have the connection, the graph, and the rules. So how many rules did you learn? You learned 5 rules. When the function is increasing, your derivative is above x-axis. When your function is constant, meaning flat, there is no change, your derivative is 0. When the function is decreasing, it's below x-axis. When you have a min and a max, your derivative will cut through x-axis, so that's where the x-intercepts are. And finally, location of vertical asymptote is preserved for these. Eventually, not yet, but eventually, just to support this vertical asymptote thing, you are going to learn that the derivative of ln x is 1 over x. We are not there yet. Now, why am I talking about this? Because if you graph your ln x, you see that there is a vertical asymptote at 0. Then you graph the derivative, and you still see that there is a vertical asymptote at 0, right? So there's another example that has it. Now, this is not something that we covered yet, but it's coming up very soon. So that's it. Your homework for this section is a lot of this graph chasing, you know, and none of this is exact and precise. You are sketching things. So don't get hung on a question, do I go closer in or do I go wide out? No. You just need to know that there is a curved line that goes there. That's it. You don't know. Also, students used to ask me, how deep do I dip with this piece here? It doesn't matter, because you don't have the function to calculate how low it goes. So as long as it's a U-shaped thing and it dips below x-axis, it's a full credit, because you are displaying your understanding that for the decrease in a function, you have negative derivative. That's right, you have a negative change. Now, I hope that you are connecting these concepts, decrease function and negative derivative, because all of the slopes on a function that is decreasing are negative numbers. So you have negative derivative. And that's that. Bye.